Hello everyone and welcome back to Clinical Cousins YouTube channel, where today we're going to talk about the renin angiotensin aldosterone system and how it slowly raises our blood pressure. So the first thing we need to know is that this is a hormone-based system that we're going to talk about. This means that it is going to be slower than, say, the neuronal-based baroreceptor reflex system, which we just talked about in our previous video. So this whole system its whole function is to raise the blood pressure, specifically that mean arterial pressure, that average blood pressure. So what happens is a decrease in our mean arterial pressure, our MAP, is going to be sensed by our kidneys. Now specifically I'm talking about the afferent arteriole, which houses the juxtaglomerular cells, or J cells as I like to call them, because they just start converting prorenin into a substance called renin. Now, renin can also be released by circulating catecholamines that activate beta-1 receptors like isoproterenol and epinephrine. So if you have any drug that activates beta-1 receptors, just know that you're going to be releasing some of this renin. So this renin is released into our bloodstream and it's just floating around, and it's like a pair of scissors. So these renin scissors are going to cut a substance called angiotensinogen. Remember ogen, like Genesis meaning the beginning? It's going to cut angiotensinogen into angiotensin 1. It's a little bit shorter. It's a decapeptide, so there's 10 parts of this substance, angiotensin 1. Now, this angiotensin 1 is not biologically active, meaning we don't really care about it because it doesn't have much function in our body as we know it right now. Now, what we do care about, however, is its product angiotensin 2, its conversion product. But how do we get there? Well, as angiotensin 1 circulates throughout our entire body, eventually it's going to come in contact with the pulmonary capillaries and the kidneys. Now, there's a sort of a sinister enzyme that we don't really like. It's called ACE, so angiotensin converting enzyme. This ACE will actually cut angiotensin 1 into angiotensin 2, which is an octapeptide. So there's 8 parts of this substance. So generally, we do not like this angiotensin 2. It has quite a few functions that can be really hard to remember, but the only thing you need to know about angiotensin 2 is that it brings the blood pressure back up. So angiotensin 2 brings it back. B-A-A-K. B for brain, A for arterioles, A for adrenal cortex, adrenal glands, and K for kidneys. So angiotensin 2 affects the brain by working on our hypothalamus to make us more thirsty. Also, angiotensin 2 will work on the posterior pituitary gland to release anti-diuretic hormone. Diuresis, right, to pee, anti-pee hormone. So this is going to help us conserve free water. So it's going to work by stimulating V2 channels in our kidneys by inserting these aquaporin 2s into our collecting ducts to reabsorb more free water. Basically, ADH is going to help us conserve more free water in itself. So angiotensin 2 also acts as a direct vasoconstrictor on our arterioles by activating AT1 receptors. They use the same phospholipase C, IP3 protein kinase pathway to really clamp our arteries down and to raise our mean arterial pressure. Now, angiotensin 2 also works on our adrenal glands, specifically the adrenal cortex, specifically the top layer, specifically the zona glomerulosa, to release aldosterone. So what does angiotensin 2 do? It releases aldosterone. Now, aldosterone is it's one of the most popular things probably talked about medicine. It's a sodium-potassium revolving door. It's basically inserted into our collecting ducts, and it sucks sodium into our blood and it spits out potassium. So sodium goes into our blood, and at the same time potassium is spit out. So what the end result of this is that our kidneys are going to retain more volume. They're going to increase our blood volume, which is eventually going to increase our MAP. So lastly, it's going to work on our kidneys as well, right? So it's actually going to work on the sodium hydrogen exchanger to increase sodium and water absorption. But what does angiotensin 2 do in short? If you're in a clinical situation, you don't have time to walk through all of this. So you just know it will bring the blood pressure back up. BAAK. It's going to work on the brain. Your patient's going to become more thirsty, and they're going to release ADH. It's going to work on the arterioles to constrict them. It's going to work on the adrenal cortex to release aldosterone. And it's going to work in our kidneys to absorb more sodium and more water to increase our blood volume. So I hope that this mnemonic helps you to remember all the effects of angiotensin II on the body. But we have to know, well, what about ACE inhibitors? What about these angiotensin converting enzyme inhibitors that I've heard about? What about the angiotensin receptor blockers that I've heard about? Well, how will I know all the different things that these drugs are going to do? Well, if you give a drug like lisinopril, which is an ACE inhibitor, or a sartan drug, which is an ARB, an angiotensin receptor blocker, all you have to do is know that it is going to block these effects. So what are we going to have if we give these drugs? If we give an ACE inhibitor or if we give an ARB? Well, angiotensin II, not going to work anymore. And what is that going to have? What effect is that going to have on the body? Well, it is going to not have an effect on our brain. They're going to be less thirsty, less ADH release. What effect is going to have on the arterioles? Well, they're going to dilate. They're not going to be constricted anymore. What about aldosterone? Well, we know that ACE inhibitors and angiotensin receptor blockers, they block angiotensin II. That means we're not going to have aldosterone release. So what is going to be in our urine? Is sodium going to come through this revolving door? No, it's not. It's going to be in the urine. But what is an effect that aldosterone has that not many people think about? That's right. Angiotensin converting enzyme inhibitors, ACE inhibitors and ARBs, they are going to help us retain potassium. So be very, very careful, because your patient cannot have salt substitutes. They have to not eat as many fruits and vegetables. They have to be really careful about their potassium intake, because they are retaining more potassium. They don't have that aldosterone. And lastly, what else is going to happen? It's going to work on our kidneys. We're not going to have that sodium and free water absorption, and we're going to decrease our blood pressure. So as always, thank you guys so much for taking the time to learn with us today, and I hope you like and subscribe for more content. Thank you.